For almost 20 years, I have spent roughly 5 hours a day thinking about one mathematical object. Not a formula, not a theorem, an object. At first, it existed only as a collection of drawings, then it became a geometry, then a system of symmetries. A machine whose closed pathways behave like arithmetic frequencies. Prime numbers are the atoms of arithmetic. Every positive integer can be built from them, but the primes themselves refuse to follow a simple pattern. Mathematicians understand their average behavior extremely well. What remains mysterious is the error, the tiny oscillation between where the primes appear and where they should appear. In 1859, Riemann discovered that these fluctuations are controlled by the zeros of a complex function. After analytic continuation, this function has infinitely many non-trivial zeros. The Riemann hypothesis claims that every one of those zeros lies on the critical line. The conjecture remains unsolved, and a valid proof carries a $1 million Millennium Prize. But the real prize would be discovering why the primes are organized this way at all. An early notebook page of Zeta Space. Most approaches begin with the zeta function as an analytic expression. I began with a different question. What if the zeta function is not the fundamental object? What if it is only a shadow cast by a deeper geometry? A complicated equation becomes natural once we discover the space producing it. A spectrum becomes meaningful once we identify the instrument that is vibrating. So I searched for a space whose internal geometry could generate the analytic structure of the completed zeta function. Begin with a cube. A cube contains 4 long diagonals passing through its center, each connecting a pair of opposite diagonal vertices. Now replace each diagonal with an entire curved sheet. 4 sheets, 2 cone points each. Together they account for the 8 vertices of the cube. The 4 sheet solutions F1 through F4 form from the construction. But the sheets do not pass through one another independently. Slicing the sheets reveals the seam curves intersecting ellipses where the surfaces meet. In the 3-dimensional seed, gamma has 6 vertices and 12 edges. Combinatorially, it is the graph of an octahedron. The geometry lives on the sheets, but the deepest interactions are concentrated on the seams where those sheets meet. Two-dimensional sheets, one-dimensional seams, zero-dimensional intersection points, a stratified object. The seed is not static, it can twist. Its regions can undergo quarter-turn transformations while preserving the compatibility of the total structure. These legal transformations form a finite, noncommutative symmetry system. This makes the seed behave less like a smooth sphere and more like a geometric cousin of a pocket Rubik's cube. But instead of colored plastic blocks, we transform curved orbifold regions attached along a common singular scaffold. Inside the seam network are distinguished closed cycles. The pi action permutes and twists their configurations, a finite machine of geometric states. Perhaps arithmetic information could be encoded not only in the shape of the seed but in its possible motions. To connect this geometry with the zeta function, the seed Imagine exciting one of its cone points. A local mode propagates across the curve sheet, constrained by the orbifold geometry at its two singular ends. A collection of these local modes assembles into a theta-type kernel. Theta functions possess a remarkable reciprocal behavior. Small-scale information transforms into large-scale information. Local vibrations become global windings. The cone points determine where modes originate. The sheets determine how they propagate. The seam graph determines how they close. The final analytic step is a Mellin transform. Theta reciprocity and the Mellin transform are already deeply connected to the functional equation of the zeta function. The completed zeta factor would emerge not only as an isolated analytic miracle, but as the spectral output of the seed. Along the critical line, the zeta spectrum oscillates and crosses zero exactly at the Riemann zeros. The zeta function may be the audible spectrum of an inaudible geometry. The functional equation relates s to 1 minus s. Its symmetry axis is the critical line, and in zeta space, this reflection is intended to arise from the seed's geometric reciprocity, a state and its reciprocal partner, local cone modes and global seam windings. A complete proof needs a rigorous spectral mechanism forcing every non-trivial zero onto that axis. This is the decisive mathematical gap. I'm not claiming it has been accepted as closed. I'm claiming that zeta space offers a concrete geometric language in which the gap can be attacked. For years, I treated the seed as a purely mathematical object. Then I noticed that its transformations have a direct mechanical interpretation. The seed naturally divides into 8 cone regions surrounding the common seam system. Magnets snap compatible regions together. Conductive tracks along the seams let currents block, levitate, or turn each region. The abstract group action becomes physical motion. Not a machine that brute forces the hypothesis, a physical model of the geometry proposed to underlie the zeta spectrum. The machine has not been yet completed in its fully motorized form, but once I saw that it could exist, the framework changed. Zeta space was something I could build. The three-dimensional seed is only one level of a larger hierarchy. The spectral tower. A point, a line-like scaffold, curved arcs inside a square, the four-sheet seed, and upward through the n-cube. These seeds can be connected into networks, seams joining into a larger web of possible propagation paths. In a large-scale limit, such a network could be studied as an effective model of space fields or information flow, speculative, but built on something precise. The seed is not the final theory, it is the alphabet. I have lived with this object for most of my life. At different times it has looked like topology, like group theory, like harmonic analysis, like a puzzle, like a machine. Perhaps arithmetic is not fundamentally a collection of symbols, perhaps it is geometry viewed from too far away. Perhaps the Riemann hypothesis is not merely asking us to prove that a collection of zeros lies on a line. Perhaps it is asking us for us to discover the object that forces them there. I did not spend 20 years searching for one more equation. I spent 20 years searching for the space in which the equation becomes inevitable.
Fortis et clarus, victor in prelio, lux nostra in